The rapid deployment of U.S. military jets to Greenland reflects a broader strategic emphasis on Arctic readiness and northern defense posture. Greenland occupies a critical geographic position between North America and Europe, making it central to transatlantic security and early warning architecture. As polar routes gain strategic importance and long-range aviation and missile technologies evolve, maintaining readiness in the high north has become a priority. Enhancing readiness in Greenland is not a sudden shift but part of a long-term defense framework. The Arctic presents unique operational challenges: extreme cold, limited infrastructure, rapidly changing weather conditions, and vast distances. Successfully deploying advanced fighter aircraft into this environment demonstrates logistical capability, interoperability, and operational resilience. The rapid deployment of jets is therefore both a training evolution and a signal of sustained northern vigilance. Greenland hosts Pituffik Space Base, formerly Thule Air Base, a key installation supporting missile warning, space surveillance, and Arctic domain awareness. Its location allows early detection of ballistic missile launches and long-range aviation routes that traverse polar corridors. The Arctic region has gained increased military attention due to shifting geopolitical competition and expanding accessibility caused by climate change. Sea ice reduction has opened new maritime pathways, increasing commercial and military activity. As a result, Arctic infrastructure and response capabilities must adapt accordingly. By deploying jets to Greenland, the U.S. military reinforces the defense perimeter of North America in coordination with allies. This effort supports continental defense mechanisms under the North American Aerospace Defense Command, NORAD, strengthening detection and response capacity. Rapid deployment exercises are designed to test the ability of units to mobilize, relocate, and establish operational capability within compressed timelines. In the case of Greenland, fighter aircraft such as F-35A Lightning II and F-16 Fighting Falcon platforms are deployed with minimal notice to operate from austere or cold weather bases. Execution begins with coordinated planning between operational commands, logistics units, and host nation authorities. Aircraft must be prepared for long-distance transit, often requiring aerial refueling and coordinated airspace management. Upon arrival, crews immediately begin setting up maintenance operations, securing munition storage, and integrating into local command structures. The objective is to validate that advanced aircraft can operate effectively even in remote Arctic conditions. This includes testing fuel management, cold weather maintenance procedures, communications resilience, and rapid sortie generation. The deployment typically includes a mix of 5th-generation and 4th-generation fighter aircraft, each bringing distinct operational strengths. The F-35A Lightning II provides advanced sensor fusion, stealth characteristics, and network-centric warfare capability. Its ability to gather, process, and share data enhances situational awareness across the battlespace. In Arctic operations, where radar coverage may be limited by geography and weather, sensor integration becomes especially valuable. The F-16 Fighting Falcon complements this capability with proven reliability and multi-role flexibility. It is capable of air defense, ground attack, and reconnaissance missions. Together, the aircraft combination creates a layered air defense and strike capability. The presence of both platforms ensures interoperability between legacy and next-generation systems, reinforcing collective defense readiness. Operating jets in Greenland presents significant environmental challenges. Extreme cold affects aircraft systems, fuel viscosity, battery performance, and hydraulic components. Ground crews must conduct specialized pre-flight inspections and use climate-adapted equipment to ensure safe operations. Logistics support is equally critical. Spare parts, maintenance tools, and support personnel must be transported efficiently. Rapid deployment exercises test whether supply chains can sustain operations without reliance on large established bases. Cold weather training also reinforces pilot readiness. Landing and takeoff procedures in icy conditions require precision. Weather volatility demands flexible flight planning and contingency preparation. Sustained Arctic operations depend on disciplined logistical execution and environmental adaptation. The deployment of jets to Greenland directly supports NORAD's mission of aerospace warning and aerospace control. Aircraft integrate with radar installations, satellite systems, and command centers to enhance situational awareness across northern airspace. Joint operations validate communication protocols between U.S. and allied forces. Pilots may conduct simulated intercept missions, testing response timelines against hypothetical unidentified aircraft entering monitored airspace. These exercises strengthen early warning networks and confirm that layered defense systems remain operationally effective. Arctic airspace is expansive and sparsely populated, requiring seamless coordination between air and ground systems. By reinforcing northern surveillance, rapid deployment drills enhance continental defense resilience. Greenland is an autonomous territory within the Kingdom of Denmark. U.S. operations in the region require coordination with Danish authorities and allied partners. Interoperability is central to Arctic security architecture. Joint exercises often involve shared training objectives, communications compatibility testing, and coordinated operational planning. This collaboration reinforces alliance cohesion and mutual readiness. Interoperability ensures that, in any contingency scenario, allied forces can operate cohesively. Shared procedures and compatible systems reduce friction during real-world operations. The rapid deployment of jets therefore strengthens not only U.S. readiness but also multinational defense integration. Enhancing readiness in Greenland carries strategic implications beyond training value. Visible deployment of advanced aircraft demonstrates capability and responsiveness. In deterrence theory, credibility depends on demonstrated readiness rather than rhetoric. The Arctic is increasingly viewed as a region of strategic competition. Maintaining operational presence and demonstrating rapid reinforcement capability reinforces stability by signaling preparedness. Deterrence in this context is defensive in nature. By strengthening aerospace defense infrastructure and demonstrating rapid mobility, the U.S. military contributes to predictable security architecture in the region. Strategic signaling through readiness reduces uncertainty and supports long-term stability. Each rapid deployment exercise generates data. Commanders assess sortie generation rates, maintenance turnaround times, communication reliability, and fuel logistics performance. Lessons learned inform future deployments. Identifying bottlenecks in supply chains or environmental adaptation procedures enhances future readiness. Continuous improvement cycles ensure that Arctic operations become more efficient over time. Training cycles also maintain pilot proficiency in diverse conditions. Exposure to Arctic operating environments strengthens adaptability across the force. Readiness is not static. It is a product of continuous testing and refinement. The rapid deployment of jets to Greenland reflects a sustained commitment to Arctic defense preparedness. As technological advancements reshape global security dynamics, northern approaches remain strategically significant. Maintaining the ability to surge advanced aircraft into remote environments reinforces deterrence, supports alliance commitments, and strengthens continental defense mechanisms. The Arctic theater demands resilience, coordination, and technological integration. By enhancing readiness in Greenland, the the U.S. military demonstrates that Northern defense is not peripheral. It is integral to overall security strategy. The exercise underscores a clear doctrine: maintain mobility, ensure interoperability, and preserve operational capability in all domains, including the High North.